Hello, and welcome to my presentation of Good Data Saves Lives, how we used FME to streamline our data export and validation to our 911 dispatch software. So to give a little introduction of me, my name is Alexandra Rutherford. I'm a GIS analyst at the City of St. Albert and have been there for almost 2 years. And before that, worked at another neighboring municipality for a couple of years and in private consulting for nearly 10 before that. So within this presentation, I'm going to discuss how increasing our FME use has decreased our export and validation time and have led to better quality control overall. I hope you'll bear with me with this recording as I would try to do it in one take, and we will see if we get there, the joys of virtual conferences. So for today's attractions, I'll be discussing the problem that we had, our data requirements, what our previous method was like our new method, and how this new the validation scripts that I implemented have ensured that our data continues to be of high quality for our 911 dispatch system, as well as a few additional benefits we've had. So our problem is the different schema requirements between FDM's dispatch software provided by Central Square and the schema within our enterprise geodatabase. So the fact that we have to export this data quarterly to have it as up to date as possible for our 911 dispatch. So for the data requirements, FDM requires that street names and addresses be parsed out by prefix, name, street type, and suffix. In our enterprise geodatabase, we often have these fields merged together depending on the data set. It also requires that civic addresses only be numeric, and we have a lot of lettered addresses within our street and parcel data sets that needed to be parsed out. Why all of this is important is because if these were not separated out each time, it triggers an error when uploading the data, and then that data needs to be reevaluated, edited, and then re-uploaded again. This can lead to a lot of time to get our data into the FDM software. And also, one of the limitations with the FDM is that it routes to a street range rather than the location of the address points. This means that all streets must have correct address range. Our data set has always performed well in this regard, but we previously didn't have formal checks in place and would manually verify before going to production. So our previous method was carried out by running about 10 to 15 scripts. Then topology tools in ArcMap would be run to ensure connectivity. These processes would take about a day to complete. Then the data would be uploaded by fire services, and any data loads errors would trigger a request for an update. So we'd have a bit of back and forth to ensure that the data was meeting all requirements on both sides, and this could sometimes take up anywhere from a couple weeks to a month just due to the back and forth. So with our new method, I reworked the scripts and was able to reduce the number of scripts required to export the data down to 1. I also included, for the actual data export, I included a few additional validation scripts and a final script to copy the data to the file location for fire services to pick up. Other benefits is that fire services is no longer waiting for us to finish the export. Because this process is so simple to run now, just with one script that calls the other scripts that are required, I simply press play whenever we need to make edits to the street network or our parcel addresses are edited, and then it's ready for fire services when they're ready for upload. So I won't go into extreme detail on these scripts, but I wanted to give you a general overview. So the tasks carried out in the export script include parsing out the alphanumeric characters to their appropriate fields, remapping the schema into FDM standard using a few attribute mapper transformers, and merging the street networks from St. Albert with the surrounding areas. For routing purposes, we only care about some of the City of Edmonton streets, which are along the Henday that joins the two, as a truck might need to route to another call within St. Albert, and that would be the shortest route, the Henday being one of the main auto routes that goes around the City of Edmonton. And so to ensure that this continues to work, we clip out areas where we have overlap and give preference to the streets in our street network to ensure that they snap properly with the neighbors. And we also merge our two address sources. We have parcels and then multi-units and a few exceptions into a separate data set. So this brings everything all together and exports the data to FDM's requirements. Then once that's finished, we'll run some of the validation scripts. So to do that, I focused on some of the common errors that we would have with FDM. So FDM will throw error for all null values. For example, speed limits cannot be null. They have to, so we have to make sure that there's a value there. I created these additional scripts to validate topology rules that ArcMap doesn't manage quite as well as we need for correct routing networks within FDM. And I also ensured that all address points where a call could originate from are accounted for in the street ranges. So to validate some of the attributes, I started with the focus on FDM, but expanded to include some of our additional business rules so that as an organization, our data continues to be of high quality. Here, the test filter identifies null values on the data sets and then sends it to an error data set for review. And that's done using the attribute creator to identify what the error is, and so that it can be easily identified for the data steward. This part to validate topology is perhaps a little clunky and requires a bit more manual revision, but it has allowed us to identify a few topology issues that were previously missed by our topology checks using simply ArcMap. So ArcMap has always allowed us to verify if each line is covered by another line, but it won't determine if it's done by two sets of two streets at a four-way intersection if all four lines are stopped. Like for example, if we had one intersection coming like this and another one coming like that, ArcMap would not find that as an error, but that is definitely an error for routing the trucks. So we want to make sure that we have the proper number of intersections. So shown in this part of the script, I was creating start and end points of each line using the snipper transformer. And then in the next part, using the points that were created with the snipper, and then they are compared back to the original street network with the point on line overlayer to count the overlaps at each intersection. So it was really through this overlap that allowed us to visually verify that the intersections had the right number of streets snapped together. So we could see here that the orange intersection at the corner is in fact a three-way intersection, a T intersection. So that's correct. The bottom one's a four-way. So we knew that was correct. I also applied an intersector transformer with a filter to remove our overpass exceptions and to make sure that all streets were broken at each intersection. I was pleased to learn that as I was coming in from a different organization, that the street network here in the city of St. Albert was in very good shape, but it did allow us to catch a couple of errors that had been previously missed, and is most beneficial ensuring that the new streets that do come online are snapped properly together. We currently have our planned or proposed streets digitized, but we don't take the time to split and snap each intersection until construction begins, because there are often a lot of changes before various streets are officially built. This part of the validation has probably been the most beneficial for catching the odd error. So here I was focused on validating that all of the street network address ranges would get address hits, so when the dispatcher would put in the address. So this part really is important for the dispatch, because this ensures that the truck can leave at the station. If it doesn't get a match, then our dispatchers will manually drop a pin to route the truck. If in the past, if we ever have a miss, then that is quickly corrected, and the dispatcher will ensure that we are notified, and so that the data gets corrected very quickly. So for this part, my general workflow was to recreate the street network for each address range included on it, and then to compare those values with the address points identified that didn't match the street. So the street ranges are, like most street networks, are made of left from to and right from to values. The first tester here ensures that the numbers are always listed from smallest to largest. So then we can, using the cloner and then adding 1 or 2 to the street to continue to duplicate all of the addresses that are within those range. Then I applied a statistics calculator to the resulting addresses to get a count to ensure that they are not present in triplicate or greater, indicating that the street segment was split, but the address range wasn't updated. And then finally, an attribute creator to create the addresses moving together, merging all the different fields together, so then it can compare it to the address points. So to continue, this created a compound key using the civic number and the compiled street name, and then an additional filter was added to parse out the certain types of parcels that don't necessarily need an address match for FDM, such as public utility lots, and then adds in an error explanation. And then I used the feature merger transformer to join the address lines calculated from the previous script with the address points, to just so that when we were doing our checks visually in ArcMap, we could see if there was any points missing. So some of the additional benefits that I mentioned earlier is us knowing that streets have been approved for construction, and parcels are subdivided a little bit earlier than we used to know. Because as the parcels have been added in, it'll now show me that I'm missing all sorts of address ranges here. So I know that I now need to go in and change those planned streets into under construction, so that they will get an address hit. So it triggers us to update the road status a little bit earlier than we did before, which helps with our GIS model that we have in the organization, where we have data stewards that sit in the individual departments. So sometimes communication could just take a little bit longer, and it just lets us know a bit earlier. So that's been a major benefit for us. And additionally, it allows us, just as kind of a integrity of the street network, allows us to know when the streets have been split, but the address ranges haven't been up. So with that count function that I had on the address ranges, it allows us to know when the roads are duplicated, like this one, where you can see that the segment was split to ensure the proper hash intersection. And I know that I just need to go in and update the street ranges here, so that they reflect reality. So in conclusion, this is the increased automation and validation has decreased the time required for our export to Central Score FDM, and has ensured that we always have proper and up-to-date data available for whenever the fire service is looking to update the data. They're no longer waiting on us for a few days later once they've let us know that they need the data ready. So it's been very helpful that way. So I'll be around for questions after this recording is done. So please feel free to ask me. Thank you.